Hi, ladies and gentlemen, this is Mr. Green, and this is my semester review to get you ready for the semester test. Okay, I will be sending this out to you probably on Thursday and then opening the test up so that you can get to it after that. Okay, so here we go. Um, yes, semester review. Okay, one of the ways that you can get ready to take the semester review is to go out there and look at all of the unit tests. They're all there, they're all open for you. So you should be able to open up any one of the unit tests and rework those multiple choice problems. If you look at them and rework them, turn them in for corrections. It could get you a few extra points here and there. But the point here is by looking at those questions, you're looking at the questions that are going to be on the semester test. There are 15 questions. Each question is worth 5 points apiece, giving you a total of 75 points. Those unit tests are your best review that I could give you. Okay? So undefined terms. This is something we brought up in Unit 1. We said there was a point, a line, and a plane. These were the three undefined terms. Everything else is defined in terms of these three terms or subsequent terms that we might have come up with. So these are the things you need to keep in mind when you're looking at um, when you see this. You're going to see what are the undefined terms, point, line, and plane. There could be a multitude of multiple choice questions that they could give you there. Okay? So, what do we do in a formal proof? We start with a given statement and we're trying to work through to the conclusion. Now, I realize proofs are hard, and you know I'm never going to give you a proof that you're going to have to do from beginning to end without any assistance. But the process of doing a proof is something that we studied in Unit 1 and in Unit 2. Okay? A proof is based upon true premises, postulates, previously proven theorems, deductive reasoning, and good logic. You follow these things and you wind up with a good, solid proof. Now, what kind of multiple choice question could you look at? It could say which one of these is not a part of a formal proof and throw something like inductive reasoning in there, or throw something like uh, a unproven theorem in there. Any of those things might be in there as a wrong answer. And you just have to realize what is a part of a proof and what's not a part of a proof. Okay? Reasoning. Reasoning is the difference between deductive and inductive reasoning. Okay? We have to know those two differences. There was a part 2 question in Unit 2 that asked you what's the difference between deductive and inductive reasoning. Deductive goes from being in small, I'm sorry, goes from being big to small. It uses previously proven theorems to work down to reach a conclusion. This is what we base our proofs, our mathematical proofs upon, is deductive reasoning. Inductive reasoning uses small to try to guess what the big looks like. It's based upon patterns or observations. This is what a lot of science is based upon. We can't prove gravity with deductive reasoning because we can't look at gravity from a big perspective and prove it in a small world. But we can look at inductive reasoning. We can look at the small effects of gravity on us and determine that and make a guess at what the big picture looks like. That's the difference between these two. This is a court of law. This is just watching the apple fall off the apple tree. Okay? Inductive reasoning is helpful in math because it gives us those ideas that help us, and then we use deductive reasoning to prove them being true. So it's possible to use inductive reasoning in math, but it's mainly deductive reasoning that we use for the proofs. Okay? Now, we came up with different ways of identifying triangles. One of the triangles that we came up and we identified was called an equilateral triangle that has three congruent sides and three congruent angles. We also talked a lot about the isosceles triangle. It has two congruent sides, two congruent angles, and the congruent sides are opposite the congruent angles. Notice how here's the congruent angle, this side here, congruent angle, this side here. These are the two congruent sides. Okay? There were several problems that you saw in the unit exams that you could look at that give you good examples of those. Mid-segment theorem. There were two mid-segment theorems. There was one for trapezoids and there was one for triangles. Now, if you look at a triangle as a trapezoid with a zero length at the top, you only have to memorize one formula, because then you can say 0 plus the other base divided by 2. That's one way of looking at it. This center line in here, the C, is going to be half of the sum of these other two bases. Same thing over here on a triangle. This center line is going to be half of this plus 0, so 1/2 of this one line right down here. That's the mid-segment theorem. You have seen a good example of how this could look in the part 2 assignment of chapter 3. It gave you that very complex drawing with a trapezoid and a triangle in it. Go back and look at that and make certain you know how to work that problem, because that is one that could give you a good example of what type of problems you could be looking at. Here's an example of one right here. If I said that if DE is 3, how could I find AC down here? Well, I know that this side up here is 0. This one is the base. The base plus 0 divided by 2. So the base over 2 is equal to 3. So if I multiply 3 by 2, that means that this must be 6. If I looked at it from another perspective, what if I told you that this one down here was 26? What would the mid-segment be? Well, 26 divided by 2 is 13. That's what that would be. That's how these type of problems are put together, okay? You just got to make certain you know how to work them. We studied the triangle congruence theorems. These theorems are ones where we have two triangles, and we're trying to prove them congruent to each other. That means all the angles and all the sides are the same. Once you prove two triangles congruent, there are some other things you can do. Okay? If we used this side theorem here to prove triangles were congruent, then we could use the CP, CT, C, corresponding parts, congruent, triangles, congruent, to say that all the angles are congruent or all the sides are congruent. So we could use any one of these to wind up with something that we could prove is true. Why would we want to do this? Well, sometimes we need to use congruent triangles to prove other parts of the triangles are congruent, because we're looking for those lengths of the other parts. If we had an example in a real world where there was a lake over here, and we wanted to know how far apart these two cities were, but there's a lake, we can't measure that distance between them, but we could draw a triangle here. And because we could then extend this triangle out, we know this angle is the same. We could measure this distance here to here, measure this distance here, out here, and we know that the distance now here will be the same as the distance over here. That's a congruent triangle, and that's how we could use congruent triangles in a real world environment. In this situation, we would have a side angle, side, to prove that that was congruent to this triangle. And then we could say by CPCTC that this side was equal to this side. That's one of the things you might need to know how to do. Now, in Unit 1, we talked about some centers of triangles. What does a center mean? It means that we're going to use that center as identifying a point at some point. The centroid, this is the one that was the balancing point of the triangle, and it was found by finding the medians. A median is an important term. It is a point that is halfway along one side connected to the vertex opposite it. Halfway along one side connected to the vertex opposite it. That's called a median. Okay? That's what we talk about with a median. Now, where those medians intersect is called the centroid. That is the balancing point. We also talked about the circumcenter. This was found by taking the perpendicular bisectors of each one of the sides. Perpendicular, 90 degrees. Bisector, dividing it in half. Perpendicular bisectors of every side. And by taking those perpendicular bisectors, they intersected at a point. That's called the circumcenter. If I draw a circle from that circumcenter with a radius of the distance to one of the vertexes, that circle would hit all three vertexes, and that's the only points it would hit in the triangle. Now there was another one called the incenter. This one I always remember because it's inside of the triangle. Incenter. And the way you found this was bisecting each one of the angles. If you bisected an angle, all three angles, those three bisectors would intersect at one point in center. And I could draw a circle that would be totally inside of the triangle and touch all three sides. Okay. In Unit 2, we started talking about the conditionals. That was an if statement. It has an if, then. Okay. If A, then B. The converse, we simply switch things around and say if B, then A. The inverse, we stick the word not into it. If not A, then not B. And the contrapositive, we do both things. We switch it around and we stick the word not in there. If not B, then not A. The thing to remember about these, this conditional and the contrapositive, are the same. They have the same truth value. The converse and inverse could also be the same, but they usually need to be proven. When you have a conditional and a converse being the same, you have a definition, because then all four of these are going to be illogically true at the same time. Okay? So let's move forward. Now, truth and validity are not the same thing. We only studied two valid forms of an argument. One was the law of detachment. It has one if statement in it. It says if A, then B. A is true, therefore B is true. One if statement. The law of syllogism has three if statements in it. If, and if. And I want you to notice the B is in opposite locations here. If A, then B. If B, then C. The B gets eliminated if A, then C. These are the only two valid forms of arguments that we came up with. Now remember, valid and truth are not the same. Valid is used to prove an argument is something that we can then believe. Truth is something that we can then determine that it is an absolute truth. Okay? Let's move forward. In Unit 3 and in Unit 4, we started talking about the properties of quadrilaterals. Now, I'm not going to go through each one of these properties again, but it is important for you to be able to pick out when you get a question like this one. If the diagonals of a quadrilateral are congruent and perpendicular bisectors of each other, then the quadrilateral must be a, well, they're telling you then the parallelogram must be a. So we know it's a parallelogram. And the diagonals of the quadrilateral are congruent and perpendicular. So going back to this, sorry, had to cough. Well, in this one over here, I can see that the diagonals might be congruent to each other, but they're definitely not perpendicular. I don't have any perpendicular marks in here, so that's not going to be one of them. This one, the diagonals are congruent to each other, but I can see they might not be perpendicular to each other. In this one, I know the diagonals are not congruent, but they are perpendicular. This one is the only one that I know of that has congruent and perpendicular diagonals. So this is the only one that I would be able to say would be an answer to this one. It has to be a square. Okay? That's how you use those ideas. Now, a kite is a quadrilateral that I didn't spend a whole lot of time talking about, but you need to make certain you understand. If you're looking at a kite like this, a kite has diagonals that are perpendicular to each other, but they are not congruent at any way, shape, or form. The diagonals do bisect these two angles, but they're not equal to each other. This side is equal to this side, and this side is equal to this side. This diagonal part is equal to this diagonal part, but that's it. Okay? Now, what could you do? If you were given that this was of length 5 and that this was of length 3, you could use the Pythagorean theorem and figure out that this is of length 4 right there. You would know that this one is of length 3. Wow, we're going to town here. We know this one has a length of 5. That has a length of 90. Has a angle measurement of 90, right? We can use the information that we're given to figure out the different parts of the kite. That's what you're going to be asked to do. So I want to make certain you understand what I'm talking about. Okay? Okay. We started talking about polygons and naming polygons. The only ones that you really need to make certain you know are 5, 6, 7, and 8. A 5-sided polygon, pentagon. 6-sided, hexagon. 7-sided, heptagon. 8-sided, octagon. The rest of these are just some additional information that might help you. Okay? And you could use it at future time. Complementary and supplementary were introduced in the first unit. Complementary adds to 90 degrees. It makes a corner. Supplementary adds to 180 degrees. It makes a straight line. They do not have to be touching each other. If they are touching each other, they're known as a linear pair. If they share that one side, that one ray. But if they don't touch each other, they could still be complementary and supplementary. Complementary and supplementary have nothing to do with touching each other. Okay? Vertical angles. This was at the end of Unit 2. Vertical angles are always congruent. Anytime I have two lines that cross each other, the angles that are opposite each other are the vertical angles. So these angles in here are also vertical angles, and they are congruent to each other. So there's always two pairs of vertical angles in when two lines cross each other. When we start classifying angles, bigger than 90 degrees, obtuse. Less than 90 degrees, acute. Equally 90 degrees, 90-degree right angle. If it's 180 degrees, it's called a straight angle. So you've got all three situations that are four possibilities there. The triangle hinge theorem was at the end of Unit 4. It said the sum of two sides will be greater than the third side. So if I give you two sides, you can add them together and get a number. You can subtract them from each other and get another number. And you know that third side must be between those two numbers. So in this situation, 12 and 17, 12 plus 17 is 29. 17 minus 12 is 5. My third side is between 5 and 29. It does not have to be a whole number. It is just some number in between there, like 18.63. That would be a valid length for a side. In Unit 1, we talked about transformations. We had a slide. That's where we simply moved something. We gave a formula for that, where we said x plus 3 and y plus 4. That's just moving the x and y coordinates of each of the vertexes. A rotation is like a wheel. Wheels on the bus go round and round. So you've got a center that you're looking at, and the points go round that center and keep moving around. A reflection is like a mirror. You're looking in a mirror, and the right becomes the left, and the left becomes the right. Okay? These three are called isometric transformations. Okay? A dilation will grow or shrink, and we will be looking at this one a lot more in the next semester. This is the one that is non-isometric, and we'll spend some time looking at it next semester. Now, Parallel lines. There were four types of angles that were formed when we had two parallel lines crossed by a transversal. One of them was called corresponding angles. You just have to memorize 1 and 5 are corresponding angles here. 4 and 8 are corresponding angles here. Those angles will be congruent to each other. We had alternate exterior angles. Those are outside of the parallel lines and in opposite corners of each other, right? Those angles will be congruent to each other. Alternate interior angles. Those are inside of the parallel lines and in opposite corners. Those will be congruent to each other. Same side interior angles. Those are on the same side of the diagonal, inside of the parallel lines, and these two are supplementary. That means they add to 180. The interior angle formula. This formula over here works, but the one I want you to remember is n minus 2. You subtract the number of angles minus 2 times 180. That gives you the sum of the angles. If you want to know what each angle is and you say they're all the same, then you can say that each angle would be equal to n minus 2 times 180 divided by n. Algebraically, this is the same thing. All I did was multiply this out and get 180 n minus 360 divided by n. Well, n goes into this one, and I get 180 minus 360 divided by n. So, same formula, work the same way. This is the one that I want you to remember because you need to remember how to find the sum of the angles. Slope. Slope is given as the rise, the difference in the y values, divided by the run, the difference in the x values. All I'm finding is how far over does it go and how far up does it go. And that tells me the slope of that line. Okay? This is something that you probably learned in Algebra 1. If not there, you probably learned it earlier than Algebra 1. Slope is something you need to know how to calculate. What we add to this one is that parallel slopes are equal. Perpendicular slopes, their product is -1. Why is this important? Because you will be using that information to determine if two lines are parallel or if two lines are perpendicular making a right angle. Distance formula, we're going to use the same things, the difference in the y values and the difference in the x values, but we're going to square those differences and take the square root of their sum, and that will tell us the distance. Formula is one you need to remember how to use. That formula is very similar to the Pythagorean theorem. How does that work? If I'm looking at the difference in the x values, I could call that A. If I'm looking at the difference in the y values, I could call that B. And the difference here is C. Well, what have I got? If I take the square root, instead of a squared plus b squared equals c squared, if I say that take the square root of c and take the square root of the other side, this is what I wind up with. Okay? A squared, b squared. Well, it's just the difference in the x values and difference in the y values. No big deal. Midpoint, if I'm trying to find the middle of two things, I'm going to add them together and divide by 2. So if I'm finding the midpoint of 2 points, I'm going to add their x values together, divide by 2, and y values, and divide by 2, and it is a point. It is an xy point. That would be the location of the midpoint. Okay? For the part 2, there are 5 questions in your part 2. It's worth 52 points. It's one you want to make certain you do. I'm going to tell you, show your work. If you don't show me your work and you get it wrong, it's completely wrong. If you show me your work and I can see what you did wrong, you're going to get some partial credit for it. So do not skip out and don't show me your work. Okay? You need to show your work. Don't cheat. I know that there are some things out there on the internet where you can find some answers. Don't cheat. I've looked them up. I use Turnitin. I can see when things are being copied off of the internet. You will receive a 0 for if I catch you cheating. Trust me. I've looked at them out there on the internet. I know what's out there. I've been doing this for a few years. I've seen these answers before. One of your questions in the part 2 is a proof. You'll use the properties of perpendicular angles to prove two triangles congruent, and then you'll use CPCTC to show that all parts of the triangles are congruent. What you're going to be given is two triangles. You've got to prove the two triangles congruent so that you can say that one part of the triangle is congruent to another part of the triangle. That's the concept you're going to be using. This question right here, it says explain inductive and deductive reasoning. Unit 2, part 2. You already did it once. Go back and look at what you answered for that. Same question. Virtually the same question. You'll be answering it again. One question, you're going to be given an object. Okay? You're going to be given some object. And you're going to be asked to transform this object. You're going to be saying, first of all, slide it. And you're going to be given a rule. And you're going to slide this object to its new location. Okay? Okay? It will be a slide. Then you'll be told to reflect it over the y-axis. Well, that means make a mirror image of it going the other way. Okay? And then you'll be asked to rotate it 180 degrees. And that means it's going to do this. And you're going to be asked for where one of these points is. It's a matter of following the directions. Do it in the exact order they say. You do it differently, you're going to get a different answer. Be very careful with it. Show your work. Show how you get each of the different vertexes, and you should wind up with the right answer. Okay? You're going to have to use the properties of a rhombus. Oh, yeah. You're going to have to use the properties of a rhombus to prove two triangles are congruent. Okay? So make certain you look at this one very carefully. So it's a rhombus to start with. Well, that means all the sides are equal. Okay? And then you're trying to prove two triangles are congruent. So look at it carefully. I think what you wind up doing is using side, side, side to say the two triangles are congruent. So look at it very carefully. Finally, you're going to be given a quadrilateral, and you're going to say you want to show that it is a rhombus. The easiest way to do this is, first of all, find the slope. After you get the slopes, prove that it's not a square by multiplying them together and see if they equal -1. Find all those slopes. If you don't do it, you're not using the coordinate proof correctly. And so what you need to do is just use those formulas. Slope, distance, anything you want to use there to prove that something is a rhombus. Okay? So this has been the semester review. And my secret word for this is going to be the end. It's 2 words, the end. So you send me a K-mail telling me that you watched this review, and the secret word is the end, and I will give you credit for attending. This is my geometry course. Make certain you say geometry in there somewhere, and I appreciate you listening. And I'm sorry I can't be with you, but things happen. I will talk to you later.